The first few slides I have here are kind of just the nuts and bolts of app services. We're going to be looking at a lot of different pieces of it, but I want to kind of start off with the architecture just to show you kind of what it is and how it works. So app services by itself is just a hosting platform. So what you start off with is an app service plan, and an app service plan is basically just a bucket of resources that you can use to carve up any way you need to use for your apps to run on. So if you can think of this like leasing a server in a way, although that's really not what you're doing, you're buying compute. So that'd be the CPU capacity of the app service plan, memory capacity, storage, and then of course network connectivity that comes along with that. So an app service plan is basically a tier with a certain amount of dedicated compute, memory, storage, and networking that is used to run your applications. And there's two flavors of that. You have Linux-based app service plans and Windows-based app service plans, and they each have various aspects to them. So the app service plan, if we can think of that like as our bucket here, it's just this big blue box out of here, and that's the capacity of my compute that I have available to me. Now, once I have my app service plan, that's what I'm paying for. Now, once I have that, I can carve that up into any number of app services. I think you can put up to like some obscene amount of app services on an app service plan. I think it's 1,000 or 500. I can't remember the exact number, but basically what that means is I can insert X number or N number of apps into that reserved compute that I have on top of whatever our operating system I have. So if I buy an app service plan that has 8 cores and 16 gigs of RAM, I can cram as many app services into that 8 cores and 16 gigs of RAM as I want. I think that's a tier. No, it's 32 gigs of RAM. Sorry, we'll look at that in a minute. If I can run 10 apps in that, or I can run a single app in that, basically what I can do is just slot in as many apps as I can into that app service plan, regardless of the app service plan's capacity. It will try to run every single one of those app services. Now, the performance degradation might happen if I tried to run too many app services in a single app service plan, because they're all competing for those shared resources that come with the app service plan. So if one app is taking up the lion's share, that is taking 75% of the resources, and I still have 25%, maybe I can slot in a few small apps to that or whatever it might be. But there's a lot that you can do with that app service plan, though, and we're going to kind of unpack all of that as we go. Now, each app service plan is divided into what we call deployment slots. And a deployment slot is basically a way to slot in an application into an app service to where I can basically keep an instance of my app running, install another instance of that, and then swap over to a new instance if I wanted to, or I can load balance between the two if I want to do some kind of A/B testing or something like that. So basically what I would do is I would install my app to this one, my initial version. My next release I will install into this one. And then once everything is up and running, I've done some smoke tests on it, everything looks good in this deployment slot, I can then swap these two around, and this one becomes my B configuration, and then this one becomes my A configuration, or my production, than my staging. And I can then swap those in and out like that minimize my downtime, but I preserve my SSL certificates, all my DNS settings, and all of that stuff like that. Or, another common use case, as I mentioned, is A/B testing between deployment slots. But basically what that means is I can create a deployment slot with an instance of my application, and then version next, I can have another version of it, and then I can load balance between those two, where I have half of the traffic going to version A, or maybe 75% of it going to version A, and then the other remainder going to version B. And you can see the performance characteristics between those two, and you can chart those independent of one another. And then at some point you can divert all the traffic to one or the other, depending on what you're trying to do there. So there's the ability to do those kinds of things with deployment slots, and that's kind of what they're intended for, is to facilitate some of that that deployment strategy that you might be deploying from something like a DevOps pipeline or what have you. And we'll look at an example of that later on. But this is really fundamentally the architecture of an app service and an app service plan in Azure. Basically, reserve your capacity, carve it up in any number of app services that you can put into that capacity, and then in those app services, you can use deployment slots to manage various deployments of the application, and then swap those in and out of production slots and what have you. So the overall architecture is really pretty simple, but it has profound implications on things like scaling and resource allocation and a lot of that stuff, which we're going to kind of look at as we walk through some of this content on these slides. So the two main drivers between which one you're going to choose from is what operating system am I going to use on an app service plan, and then what framework am I going to use. So out of the box, App Services provides a number of support for a number of popular platforms. Depending on which one you're using is going to depend on which operating system you're going to use. Now, Windows tends to be a little bit more expensive than Linux on App Services. So an App Service plan on Linux is generally cheaper because you're not paying for licensing on the Windows operating system under the hood, but at the same time, it does support platforms that you might have for legacy applications on Windows that don't run on Linux. So you just have to kind of figure out what you're going to be running and which one of these is going to work for your application. So once you've selected your app service plan, which is going to basically choose your operating system, then you can install an app service, and the app service then will choose the platform on the operating system. So the app service is going to be one of these platforms, and then the app service will allow you to install your app into that app service. Now, a single app service plan can support any number of app services with different platforms. So if I have an app service plan that's Linux, I can run I could run side by side in the same app service plan something like a PHP app and a Node.js app in that Linux app service plan on the same app service plan, but they're using different app services. So they're using the same underlying compute. They're sharing that resource and that underlying compute that comes with the app service plan, but I have two different apps in two different platforms. Both are supported by Linux, so that means that I can run both of those in that context. Now, you kind of have to figure out which one of these your application is going to be able to run on. Some of them are supported on both platforms, like Node.js, for instance, is supported on Linux and Windows. However, sometimes Node.js applications are written in such a way that they only support Windows, or maybe they only support Linux. If it's invariant, then maybe go to Linux to save a buck or two on running it. If you need integrations with Windows, then choose that. Just depends on the context of what you're doing. Now, if you're running PHP, you have one option, Linux. Although you can run PHP on Windows, the native support for it in app services is on the Linux platform. Now, App Services recently added support for Java, which is a great offering now. There's a lot of support for Java-based applications outside of App Services with something like Spring Apps, the Spring Fabric that's now available, which is designed specifically for the Spring framework. But if you have like old Tomcat or JBoss or old applications that are written in more the J2E stack, that would be where the app services would come in handy, and you can run those on this. And with the Tomcat based applications, you can run those in Linux or Windows. But if you're using JBoss, you would have to run that on the Linux platform for that. But that's a really kind of a new addition for this, which I'm kind of excited about, because it does bring something to app services that wasn't there before. And Java's always kind of been a third party, but now it's first party inside of the Microsoft context now. And of course, .NET runs well on that. And then these are kind of the open source languages, Ruby, Python, Node.js, and PHP, which are popular frameworks. And of course, if none of these work for you, there's also the ability to run containers, which if there's a platform that isn't a first party offering, you can bring your own platform with a container and run that in Windows. And we're going to look at or Linux, whichever context you might be using. We'll look at an example of that later on, where we can use a container to run something on app services that is none of these right here. It's not any of these. Actually, I think it's the app I'm going to show you is mostly written in C, and it's implemented in implementing a proprietary web server that none of these would be able to run. So that gives me the ability to bring my own platform, if you will, that would fit into the platform as a service offering on Microsoft's Azure without having to spin up virtual machines or use something like Kubernetes or something else that might be a little bit more work than App Services offers. So that's the supported frameworks. Let's talk about two other concepts. One is related to scaling, and the other one is the resource plans themselves. So this is a breakdown of the app service plans. I want to talk briefly about this because this will kind of give you an idea of the various things that you can get out of it. So this is the tier. It's memory, compute, storage, scale, and purpose. So App Services has a ton of different tiers that you can choose from, and within those tiers you have basically three options with exceptions. But the idea is that they all kind of have different intents, and any one of these tiers can be selected for Windows or Linux. But the idea is that you choose the appropriate tier for your application's needs so that you can get the appropriate kind of performance that's going to be for your application. So the first one is free. If you just want to kick the tires on app services, you can use app services free tier. And this is good for just, hey, I want to host something on an app services. It doesn't have a lot of options turned on. It's restricted to 60 minutes a day. But if you just want to test something, or just play around with app services, this one's a great option. If you just want some initial exposure, you can sign up for an account. And then with this one, you can just run this free of charge on for dev test purposes. It gives you a very small amount of storage and memory, but it does give you the ability to at least tinker with some things and for kind of sticking your toe in the water for app services on Azure. The next one is the basic tier. This one I like for dev test purposes. It's really not intended for production workloads. So again, another dev test tier. If you need something that's beyond that 60 minutes right here, this is a great offering. And this is, it comes in three varieties, a B1, B2, and B3. And they basically have a scale, exponentially. So this one, has a 1 3/4 gigs of RAM, 3.57, 100 ACUs, 200, 400. This an ACU is basically 200 ACUs is roughly equivalent to a vCPU in the Azure context. So if you could think about this as like half a CPU or half a vCPU, this is a full CPU, and this would be about 2. And then it gives you 10 gigs of storage, and then the scale is 3 manual, and so on. Next tier is the standard tier, and this is the first production-oriented tier. It's still widely used, although Microsoft's not promoting this one as much as they used to because they're pushing more folks to use the premium tiers. But this one's still available, and if you need to sign up for something that doesn't need much compute, this is a pretty decent offering because it's fairly inexpensive to run. And typically I use this one for entry level type production workloads. So, S1, S2 for entry level or very small apps, S3 for some larger apps because you can get away with that. It's more of a dual core setup with 7 gigs of RAM, which will work for some apps that don't require a lot of compute. So that's a good offering there. And now we're getting down to the premium tier. There's 3 tiers in the premium tier. There's P1. There's the original premium tier. There's PV2 and PV3. They're all pretty similar in that they have 256 gigs of RAM, and they're all oriented around production-oriented workloads. And they have 20. You can scale up to 20 instance auto scale. You can scale apps up to 20 instances of an application. And we'll talk about the scale in just a second, but what that means. And then you have the V2 tier, which went to this basically incremented. It's at the baseline at 210 ACUs, and then the scale was an additional tier for the P3, which had an 840. Which is basically a 4-core type setup for the applications on this one. And then they recently introduced the PV3, which they went to a vCPU model in this one, and the vCPU is roughly about 200 ACUs. I think the exact spec is 195 based on their compute. So if you the vCPU, a two vCPU core, a two vCPU would be basically the very similar performance to what you would get out of a P2 V2, but a P1 V3 is actually cheaper than a P2 V2, and so you kind of get a better performance tier right here. So if you're not sure which one to use, default to the P in the premium tier, go to the P V3s, and you'll still get the 256 gigs of RAM or 256 gigs of storage, 8 gigs of RAM, 1632 for the memory, and then two 4, or 8 vCPUs. And this is getting into some larger apps right here for websites and that kind of thing that you might want to use for that. And they also did increase the number of available scale, which we'll talk about in the next slide right here. So that's kind of breaking down the app service plans for you. And then once you reserve the capacity, you can take any of these plans and then carve them up into as many app services as you can fit into the available resources in an app service plan. So I could probably cram quite a bit into one of these P3 V3s with 32 gigs of RAM and 8 cores. Unless it's a large application that's getting tons of traffic, then I might just need a dedicated one-to-one correlation between my app service plan and my app service under the hood. And so depending on what your needs are, we'll look at some examples of this in a minute, but that's really what these are intended for, is just here's your resources, carve it up depending on your app's needs. And so that's really what this is aimed at. So with that in mind, let's look at the scale right here. And this is another feature that is useful for certain kinds of applications. And we're talking about scale. What we're talking about is instances of an application. So this is associated with the app service plan, not the app service. So that's one of the common misconceptions with scale. The scale is tied to an app service plan. So when I start to scale up an app service plan, what I'm basically doing is multiplying the instances of an app service in the app service plan. So if I have two app services inside of an app service plan, what ends up happening is I end up multiplying both app services by the number of by the number of instances I have. So I would get 4 total apps if I had 2 app services running in my app service plan. If I had 3, I would get 6. If I had 2 instances, I would get 2 instances of each app service running if I had 2 instances declared in my app service scale. So that's something to consider whenever we start to look at this. So there's 2 kinds of scale in app services. There is scale up and scale out. So scale up is where basically I increase the amount of RAM, CPU, and storage. Scale out is where I increase the number of instances for my application. And as I said, it relates to the app service plan. So if I have a single app service plan and I want to scale out the number of instances of that app service, in that app services, I can scale up to 30 in the premium version 3. I would get 30 instances of my app service if I have a single app service running on my app service plan. And as I said before, I would get if I had 2 app services running on a single app service plan, I would get 2 times the number of instances that I have in my scale out right here. So I'd get total of 60 instances, but half of those would be one app service, half of them would be the other app service. So think about when you scale out, if you're scaling out, that you're scaling out all the app services in your app service plan. Now a scale up is basically where you're just going up in the tier of your app service. So you can dynamically scale your app service plan to increase the compute capacity of your application. So if one day you're running into a scenario where you need more RAM or more compute, you can go up to the next tier. Say I'm doing a P1 V3, I can go to a P2 V3, add more compute and more RAM. I don't increase my storage, or my scale out instances, but I do get more compute capacity, which will allow my application some breathing room. So maybe I can scale out if I need to, and not bottleneck the CPU or create backlogs of requests and things like this. But the scale up typically works for monolithic applications, and the scale out works for auto scaling. And it can also work for manual scaling if you want to do that. But this is a great auto scale, which we'll look at kind of what that looks like and as we go through this in the next some examples I'm going to be running out here in a minute. So some other features related to app services. So there's just tons of things that I'm not going to get into, which I've kind of hinted at some of these already. There's just a ton of things that you can do with this that they just keep adding new offerings and new features of this. It's because it's one of the most popular features on Azure. You have integration with popular DevOps platforms. So there's native integration with GitHub. If you want to GitHub Actions, you can deploy for that. I'm gonna look at an example of that later on. You can do it for ADD deployment with deployment slots. We've looked at that already. It's got tight integration with other Azure services. There's the ability to basically create connectors to other apps services on Azure, and it will basically pre-populate your environment with connection information, so you don't have to publish that with your apps, with your DevOps pipelines, or maintain some kind of insecure integration with that. It just basically gives you secure ways to handle all of that. It's got App Insights integration where you just click a box and it turns that on. You can create private endpoints of VNet integration, so you don't have to publicly expose this. You can do custom domains with custom SSL if you want to do that. And that's great for public-facing websites if you want to have brand identity and that kind of thing. It's got first-party RBAC controls with Azure AD. So basically, you can control access to app services and that kind of thing. It's got built-in health probes for site health and back-end automation with web jobs, which I'm not going to get into that today as well. But again, this is just kind of highlighting some of the features that we can get into. But I want to talk about this mostly from the use case side now. So I've got 4 example applications that I want to look at in this context to show you kind of the feature set, what you can do with app services that are just completely different kinds of applications. And the idea is to kind of give you broad exposure to app services that will try to give you a feel for what you can do with your apps on app services as well, to show you what this platform is kind of intended for. So it's this kind of Swiss Army knife that gives you a bunch of features that you don't have to use, or you may or may not use, depending on what they are. You don't have to use all of them. You can only use you can use a subset of them. But once you configure them all, it can run quite a number of different kinds of applications. So this is my first use case that I have here. So I've seen this quite a bit with a company wants to rehost their website. A lot of companies use WordPress, and this is one of the canonical examples for app services. App services is a great hosting platform for WordPress websites, and for and depending on the website, depends on the scale that you can cram into this, and it's backed by MySQL databases, MariaDB databases if you want to use that on Azure. So WordPress, the WordPress platform allows you to basically create a website that has a backend content management system, but it's intended around blogging, but you can use it for all kinds of different things. You can use it for different kinds of forums. You can use it for eCommerce. It's a very versatile platform if you've never used it before. And it runs about 40% of the websites on the internet. So it's insanely popular, but it is heavy. It can take on a life of its own because it is highly customizable. You can make WordPress do whatever you want to. So this scenario is a company needed to rehost their company website and a managed infrastructure to reduce costs. That's kind of their goal. They've been hosting this on premise for a long time, and they want to reduce their cost and for maintaining the site. So they basically just want to get out of the business of babysitting servers to maintain the site. They want something that's out of the box, highly available, and something that they don't have to worry about all the headaches of patching the operating system and doing all that. Well, they choose app services, and so they're going to migrate this into app services. Well, out of the box, WordPress does require quite a bit of RAM and compute to run because it is a heavy framework. It does use an external database. It can, again, use MySQL or MariaDB, both of which are available on Azure. And it's using a rather modern stack because WordPress gets frequent updates. WordPress, they constantly are fixing, adding new features to it, or patching bugs or patching vulnerabilities, and always updating it to work with the latest versions of PHP. And so it is a modern framework. It's a modern platform, although the architecture is somewhat antiquated, given that it's more of a monolithic style architecture, because it's an application that uses, interior architecture. You have a database, you have middleware, and a front end. And, the interior application is you run the GUI in a browser. You have this all integrated backend platform that's all integrated, admin, front end, and all that, and it runs on top of a RDBMS, which is very common for applications like WordPress that were written in the 2000s. That was very common architecture, and it still exists in a lot of applications, WordPress being one of them, and they are not going away anytime soon. So with this particular application, we just basically want to migrate it to Azure App Services, and it's pretty straightforward. The main thing that we have to do is migrate the database, get it up and running, and then reconfigure WordPress and install the content. So let me go look at an example of this. Let me pull up my example here. So this is my resource group. This is all I've created a single resource right here, resource group, and for demo purposes, I have 4 different app services right here. I have 3 app service plans. My 3 app service plans are intended for different use cases. And so my WordPress site and this Node.js website share this Linux host right here. So I have those both inside that app service plan. And then I have this other one called Node app that's running this Node.js one right here, which we'll look at in a moment. But my app service plan for this one is basically, it's a single instance out of the box. I don't need any kind of multiple instances of this. In fact, that would probably not work well with this because app services, because this is more monolithic in its architecture. Now you can make WordPress run HA with multiple instances of it, but you don't have to with app services because the architecture underneath is sensitive enough to know whenever you're going to when it's going to experience outages that you can it'll move the app around to different backend compute without interrupting your application. So you can keep your application up and running even though the underlying compute might change for your application. So that's one of the advantages of something like an app service. Is that I don't have to really worry about configuring on VMs and things like that. It just comes out of the box with it. And so I can just deploy this to an Azure app service and not have to really worry about it and just keep it in this monolithic architecture. And then just connect it back to its app service to this MySQL database right here. I'm using what's called a Flex server on MySQL, which is again one of the many offerings for MySQL. You can also run this on MariaDB as well, and it's basically a low-cost option for dev test purposes, or you can scale it to use a large storage mechanism with a lot of cores. This is using burstable cores under the hood, so I can reduce the cost of my compute given the nature of this application, which is incredibly bursty given the nature of this website. So it allows me to maintain low costs by using the burstable configuration, but I'm also using, I think, an S1 shared with another application. So the cost of this is divided among all of the applications I might have running in parallel with this application on Azure App Services. So just to kind of give you the context here, this is my database here. Let me go back over to my app here. Look at my app service WordPress instance. So I don't really have a whole lot to show on this other than, it's an app service running a WordPress site. And if I open it up, it'll load WordPress. And I'm not using any custom domains or any of these features, but if you look at the scale up and scale out for the app service plan, this one's just going to look at it's using an S1 to run this. And I don't have any scale out. I only have a single instance of this one running, so I don't need to scale this one out. And so this one is, again, pretty straightforward in its deployment. But once I deployed this one to PHP version 8, right here, I'm running this on Linux using PHP. Okay, I'm using 7 on this one instead of 8, so I'm using PHP 7.4. And I basically just took all the content off the old site and then FTP'd it up to this using the FTP deployment. And then I reconfigured the database, and then I got my website up and running. And this is Blaze's monolithic WordPress site, and it's just a simple WordPress site, pretty vanilla install at this point, but it's very straightforward in this particular implementation. So this is one of the canonical examples, not very complicated, but some of the other ones are going to get a little bit more esoteric in their implementation. And so I'm going to spend a little bit more time unpacking those. This one, again, is pretty much an out-of-the-box experience. Very little needed to make this one work. It's just a WordPress site. So let's look at my next example, which is going to be my next example is a classic ASP.NET e-commerce website. So the scenario here is where I have a company that has a tried and true e-commerce site for selling their products. They've been using this for years. It was originally developed in ASP.NET 2.0 with a SQL backend. So again, this is another monolithic type application. It was developed in ASP.NET 2.0, which if you know anything about ASP.NET 2.0, that came out in the early 2000s, circa 2002, 2003, if I'm not mistaken. And so if you could think about this as running on an old stack, 20-year-old technology, they need to move it off an aging, like currently the scenario here is they're running this on Windows Server 2008. That's been out of support for years now. Microsoft has not supported 2008 in years, and it's old hardware. They just haven't had the ability to upgrade it, or the know-how, or the need to upgrade this website. So they don't have any developers to redevelop the site in modern tech. They just want to keep it as is because it works, but the server they're running on this is showing signs of failure, and they just need to get it up off that server. Well, fortunately, with Azure ASP.NET, even 2.0 can run on app services out of the box. So basically, to make that run, you can use ASP.NET 3.5 because it's backwards compatible with ASP.NET 2. So it'll allow you to use something like web forms and this kind of application in the context of Azure App Services. But given that this is an ASP.NET 2 application, this one's going to have Windows only support because ASP.NET prior to core didn't run on anything other than Windows. Now with newer versions of ASP.NET, you can run that on Linux, Windows, or Macs. ASP.NET 5 moving forward, 6 and 7 are all going to be running on cross-platform. So you can run newer frameworks on Linux, what have you. But this application won't run on any of those new platforms because it was written 20 years ago and they don't want to redevelop it. The site is old, but fortunately, the offerings on Azure will allow this to run because the SQL backend is on Azure. SQL allows me to use basically older style databases in a modern platform as a service offering on Azure. So this one originally was running on SQL Server, I think 2000, and then using ASP.NET 2.5, but basically migrated the data off of that onto Azure SQL, and then took the app and then installed it on app services without having to recompile or rebuild the code. Is moved the content over and reconfigured it to hit Azure SQL instead of the on-premises databases, and it works. So let's go take a look at this one. Just kind of look at this one and how it works. To make this one work, again, I chose an app service plan for this one. Let me go back to my demos here. I chose an app service plan for this one to be Windows-based rather than Linux-based. This is my app service plan for this one. It's still, I think, an S1 for this one. I'm using a D1, so this is a development instance right here. So the Windows tier has a D series, which I didn't cover. It's not as common, but it's a D. It's for development. That's for this purposes. That's fine. It is it's similar to the B series, but they don't have. There's only one instance of it. It's a D1 development plan, which allows me to run Windows apps on this one. It's a cheaper offering, so it allows me to do dev work. And so this one, I basically configured it to use a Windows app service plan with the back end being any number of various configurations. So with this one, let's go into my app service. This app service right here. If I go down here, to my apps and I go into this one right here, I can show you that this one is running a .NET 3.5, which I said is backwards compatible with the older versions of .NET. So the configuration here is, let me go back to my configuration. If I look under general settings, it'll allow me to pick the platform. And this one is using ASP.NET 3.5 and 32-bit it's only. And I did, to make this one work, I basically just set this one up, and to deploy it, I took the compiled code, all the code that was in IIS as it was, and FTP'd it up to this app service using the FTP option for deployment. And then basically set the managed pipelines versions to classic, because this is using an older version of ASP.NET. And once I did that and I FTP'd the code up, everything works. So I was able to run this particular application using ASP.NET 2, although it runs on ASP.NET 3.5, set the managed into classic, and then reconfigured the web config file to hit a database, which again is just running a SQL Server database, nothing fancy there. I think I'm using the server list here just to save on costs here, but it's just a SQL database right here that has some basic data in it that runs this application. So let's take a look at this one. Again, it's a legacy application, so just to show you that this actually will run old websites, you can move some stuff into this. Now, it's not going to work for everything. This is the old website. This website even looks like it was built in the early 2000s, based off the UI, the user interface cues here, and it's backed by the SQL database. So it's just an e-commerce website. So I guess you can delete this, update that, and it actually runs pretty snappy on this, considering that this this backend is this was designed to run on really old hardware in an old framework. So it's just taking advantage of modern hardware using old platforms. So it's pretty snappy on the back end, considering just how old this really is. So again, an example of a legacy application, more monolithic in its architecture, but still able to run on a platform as a service on Azure App Services. So we've seen two examples so far. We've seen a more modern app, which is WordPress, monolithic architecture, but still a modern platform running in the Linux context. This is an old app, ASP.NET 2, running in the ASP.NET world on Windows. So this is one of those types of applications that you can get inside of app services as well. So let's look at our third example, which is going to be something that you might use this for as well, and that is a microservice API written in Node.js. So again, something completely kind of different from what you might do in than what we've seen so far. So far, we've just seen kind of apps, like apps that run on a platform, which is Azure App Services, that are more app-centric, more monolithic in their architecture. But this is a microservice API written in Node.js. Now, this is not going to demonstrate all the complete suite of the ways that you could run microservices in the app service context. But a few things that you could do with this is run microservices, scale it out, and then you can, if you need to run it backend services for this, you can integrate it with things like web jobs, which basically allow you to have backend services that do things on a cron or things like that. Or you could wire up things like you can run Azure Functions and trigger things based on front-end APIs, and which Azure Functions do run on app services fundamentally. And so you can use all these platform as a service offerings on Azure to create different kinds of applications that don't require things like using Kubernetes or something like Service Fabric or one of the many other offerings like on Azure that are more complex. But this one is a company that needs to rehost their microservice architecture on Azure on a platform as a service offering. They currently run this on premises on a server. The API is used by front-end applications that are not installed with the API. So the API is completely independent of the front ends that use it. And so the API needs to scale under load so it can meet peak demands under peak time right here. And the company would like to the potential to scale out the API for future business grow as the future business grows. So basically what they're looking for is the ability to scale out the application as as potentially as the business grows, but they also want to have dynamic scale as well under load. So the dynamic scale under load would be a great use case for the scaling features that are built into this, as well as just using one of the native hosting models, which is Node.js. This one also, I wired up to use GitHub to deploy this. So I'm going to show you kind of the scaling features in connection with this particular example right here, and then also show you some of the integrations that it has with GitHub to show you where you can use GitHub to do deployments to this as well. So this is one of probably a more modern context for this, but again, another one of those kind of use cases that it shows you the diversity of the kind of things that you can deploy to this. So let's take a look at this one. This is my Node.js application. This is actually sharing the same app service plan as the website that I showed you first, the WordPress website, because both of them are Linux based. It's the same app service plan, but different stacks. So let's look at this one's configuration right here. No, this one is not using that stack. Sorry, scratch that. That's the next one. This one has its own app service plan because I'm scaling it. This one's using Linux. So if I look at this one, I'm using Node 16. I think I can use Node 16 or 14. And I'm using LTS version right here. There's my startup command. And this one, I am using a Linux host to host it. So my the scale that I have this one set up right now, I think I was just using an S1, which allows me to have 10 instances of it. But if I needed to grow this, I could go up to a P3 or a P2. So P2 would give me 20 instances. This one would give me 30 instances if I needed to grow it and to increase the business cases that I might have as this app grows. So this will allow me to scale more as I grow this application or as I grow the business. I have the potential to scale up or scale out in this case, but I'm going to show you more of the scale out in this case, which is currently I just think I have it manually scaled to 10 instances. But if I wanted to create a custom auto scale for this, what I can do is I can scale out the number of instances here. I can set a minimum number, a maximum number, and a default to 1 right here. And then I can add the conditions right here for auto scaling. So if I want to do it based on times, if I know that I'm going to see spikes in traffic between these hours, I can do that. If I want to do it based on a schedule, I can do that, or I can do it based on a different metric. I can do that as well between those kinds of instances as well. Another thing that you can do with this is an auto scale that's based on some of the metrics that you have available. If you want to do that, a specific instance count based upon a metric right here, the metrics would be something that you can do. The scale condition executes we're edit my condition right here, and where is the auto scale condition? Scale based on a specific mesh add rule. There it is. Here's my scale rule. I was looking for that link. You can do it. This is where you can do it based on your metrics that you might have. So if you look at your different metrics names, you can do it based on CPU percentage. That's a common one. So scale it based on the amount of CPU utilization. You see that growing. You might want to increase the number of instances if it's single threaded, especially. Another one might be TCP usage. If you have a TCP stack, or if you see HTTP link might be one that you use for this. You might be using different kinds of TCP weights, different kinds of scales that you can use for that given application right here. So these are the metrics you can scale on, or you can do it based on time index, and you can kind of figure out what that's going to be for your application, and go from there. So that's kind of the nature of the scale out that you have here. I currently have it on a manual scale, just using 10 instances. I wanted to do it this way because this way will allow me to show you that it actually is doing a load balancing configuration across the application. So if you're going to scale out, remember that I did say that it's going to scale out the number of instances per app service that you have in your app service plan. So if I have 2 app services, I'm going to multiply each app services by the number of apps instances that I have. So if I have 2 app services, I'm gonna get 10 instances of each app service running. So for this particular app service plan, I'm only gonna have 1 app service running in it because I want 10 instances of that app service running in this particular API for this particular instance right here. So this allows me to have that dynamic scale if I want to, but it's one of those things that you can do with this particular kind of instance right here. So let's go ahead and see what this one looks like. It's just an API. I think I have Postman up right here. Let me pull Postman over to this one right here. And I will show you what that looks like in, come on, Postman, there you go. And this is just calling out to the endpoint right here. If I hit send, it's going to send the request, and I'm getting some JSON data back. So if I notice this is an instance ID right here, and this is the host name. If I hit that again, I should get a different instance. I need to close Teams out. I thought I did already, but I guess I didn't. You keep getting pinged by all these messages here. Let me quit Teams. I'm getting new instances of this as I click send. You can see that I am getting a new instance ID right there and a new host ID. So I'm just refreshing that. And so that's because it's load balancing it across each one of those instances that I have running behind the scenes on this particular app service. So if this one responds pretty well. I mean, it's not the best performing application. I think it's because I have it on a fairly low tier. If I want to get better performance, I would probably go up to a P or something like that, and I would get better performance out of this application if I wanted that to have that better backend performance. But if not, otherwise, you can use the S series, which I'm using for this one, or if I wanted to get better ping times, I would use the premium tier for that. So let me close out Postman here. And let's go back and look at our last instance, which is probably going to be the most unique of all of these, which is one of those things that's going to kind of show you just the kind of crazy stuff that you can do with Azure App Services. And this one's kind of looking at it through the lens of scaling. Oh, one more thing about this one. I do want to look at the back end for this one with GitHub. Before we go change gears here, let me go over to GitHub and just show you the GitHub integration with this. This particular one, I went to, I basically created a backend for this for my, for this particular Node demo. I think that's what this one's called. This one is just a Node.js application that is deployed to that app service. So using GitHub Actions. So this one, you can see that I changed some things here. And basically what this does is it triggers on a push to a main branch, and then with a GitHub action, I can actually deploy this into my app service automatically. If I had multiple branches, I could have gated check-ins and do all that kind of cool stuff with GitHub. And with this integration, what this allows me to do is if I wanted to deploy this into a slot, a deployment slot, there's a switch inside of the application where I can swap that automatically when a new deployment goes into that deployment slot. And so basically what I would do is I'd wire up my action here to go into my deployment slot. And then there's a checkbox that says switch automatically for production. Once I deploy it, it switches to production, and then that goes live. Now I don't have to configure it that way. I can. There's a lot of options. There's a lot of ways you can configure this stuff. But this is just using a GitHub action. So if I change anything in my repo right here or over here, if I go back to my code, it doesn't matter what I change, any kind of push into my repository. Let's just change my my code right here. This is the actual code right here. It's not really doing anything. I could change maybe this property here from host to host name and spell it correctly. And that would deploy it to commit that change, and then that's going to create a push into my code repo, and then that's going to trigger my action, and we should be able to see the trigger right there deploying that to my application. And we can come back and look at that later on if we want to. It usually builds pretty fast because it's Node. It's fast. There's nothing to compile. So let's go back and look at our last example. and then we'll wrap up with some Q&A if there's any questions that folks might have. So back to my deck over here. Now this is, believe it or not, something that I've seen before. Maybe not this exact implementation, but what happened is I had an application that was a customized stack running a DOS application, legacy DOS applications that were accessed through RDP. Now, if you don't think that DOS applications don't exist in the world, the modern world, they still do, because there's a lot of like old code that was running businesses prior to the advent of Windows, and even after Windows, probably for the better part of the decade, almost even 15 years after Windows became a thing in the early 90s, that people were still using old legacy DOS backend systems to run businesses. Some of those are still around because for whatever reason, they don't see a need to upgrade it, or there's just some critical piece of functionality about that application to run it. And they just found new and better ways to run these in the cloud, be it on a VM, and they typically want to do it on an RDP session or something like that. So they want to, but this particular ask is, how can I expose this where I don't need VPNs and I don't want to run RDPs? I want to do something that's more modern. There's a lot of ways you could attack this. Well, this particular one, I was just a curiosity, see if I could do it, and it's been picked up by some people that have tried to do similar approaches for various applications for running DOS. And the one I'm going to show you is not exactly that, but it's basically using the stack. And basically, they expose this through a session running in a browser, so they don't have to have these VPN connections. They don't have to have RDP or any of this infrastructure. There's no custom software. They just basically need a browser and a URL, and they can expose this application, and it will run. And that was kind of the requirements. And this one is going to have backend using shared storage, using something like Azure file storage. So for this example, this is running all on platform as a service. There is no virtual machines. So this is all going to be running on platform as a service, but it's going to be running a DOS app that's going to be using shared hosting off of something like a file share on Azure Files, which is built into storage accounts, if you've ever used that before. So that's kind of the context for this particular use case. And it's using a stack that is basically running a DOS app. So out of the box, this one's going to be using something that's not supported by app services. To make all this work, basically what I did to make it work was I created a container app that took the DOS app and used DOSBox, which is a hosting platform for DOS applications. It's kind of like a compatibility layer that allows me to run DOS applications. And then I ran that in a container using a lightweight version of X Windows, which is the Linux analog to desktop environment, without a lot of the window Chrome and a lot of the file manager and all that. And then on top of that, I put it on a VNC client, a VNC server to capture the output from that, and then put a wrapper around that. That's basically a web server that is written in C that takes the output from VNC and then encapsulate it inside a WebSocket. And then there is a VNC client that runs in a browser that can then read that stream and then allow you to interact with that application in the context of a browser. And so that's how this stack works. So it's pretty intricate in terms of, I'm not going to get into the details on the stack per se, but it is interesting what you can do with this stuff. So let's go take a look at this one and just take a look at the kinds of things that you can do with this is again another way that you can run app services in Azure. So this one is using a container. Let me go back to my demo here. This one is using a container and it's using a file store. So this one is using a Linux container. So it's running in the same app service plan as that WordPress website, the first example we saw. And this one is called Blaze Game. And it's using a file share backend. So to do that, I basically created a file share on a storage account. So in this file share, I have this file share right here. And this would work for any DOS app, but this one I have Commander Keen. installed on an Azure file share. And then what you can do with app services is you can take that file share and mount it into a container running on Azure app services. So this one is running inside of, let me open up this particular app service right here. And this one allows me to, look at my configuration. You're going to see that I am running this using, these are the environment variables. It's using these are my Docker command settings right here. That it's basically pulling this down, the image down from Docker container registry, and then it's installing that on my app service, and then I can put all the different kinds of things in front of it if I need to for custom SSL, all that kind of stuff. But it's fundamentally using a Docker container underneath the deployment right here for this particular one. I'm running a single container, but you can run Docker Compose. And you have, I'm just using Docker Hub, and that's the container image right there. But what I did for this particular one is I mounted that file share so that I could share those files of the backend using a path mapping. So this allows me to basically take a file share right here, this one called DOS Games, and then have read-write access to that Azure file share within the context of my container right here. So it's going to mount that at a storage mount point right here in my container once it's up and running, and then I can write all of my data into that file share rather than writing it into the container. And that way anything outside of that container can access the data that this particular container is actually interacting with, even though it's running this ancient technology that's 30 years old. So ancient is relative, I guess, but in tech, anything older than 5 minutes seems like ancient technologies. But this is running something, oops, I need to type the password in correctly to pull this up. And I think I've already installed this, and this is loading a game that was published 31 years ago in a browser, and the storage for this is backed by file storage, but it's again running in a browser as a front end for this particular application. So I have Commander Keen, old DOS game. This is running a little sluggish on this one because I had that WordPress site, kind of running in parallel right with it. But if I was to run this on by itself, this would actually be a lot more smooth. Since we're running in slow mode right now, but this is again, I need to scale my do a scale up on this, right? For this to run smoothly. But this is running, again, old technology in the context of a container on app services. So there's again, just showing you the kinds of things that you can do with this kind of technology. So, the sky is the limit, really kind of what you can put on app services. There's a lot of different ways that you can run legacy and new platforms. Oldest one I'm running today is this one. It's 30 years old with modern tech to kind of support it. But then I'm running, some of this more, updated stuff with this WordPress site, and then this one right here. This one did deploy. So let's take a look at that one back in my Postman, or I could just pull it up and show you that I did change something substantive on my my front end for my Node.js application right here. If I click on this one, it should have host name now. Yeah, that's the change I made in the code, and it's still load balancing it across all of those different instances that I have in the back end. So again, modern tech, old tech, something in between tech. You have these options on Azure to run different kinds of platforms, so you can kind of contextualize your application and then figure out how you can use app services and the features of app services to run your apps on Azure. So let's take questions right here. And let me see what we have right here. The question feature, if you have an Azure question about this tech, please post it. I'll gladly try to field all these. And if you're willing to stick around for a little bit, I know we're a little over time, but we're glad to field these questions if possible. So first question is can you run WebLogic in this? I think you can run WebLogic. I think there's an option for WebLogic on app services. Don't quote me on that though. I think there is an option. There is a Tomcat, WebLogic, and JBoss for Java. I think that is supported, so you should be able to run that on this. If not, then you could run it in a container. I know that WebLogic is supported in containers, so you could definitely containerize it and put it in app services. WebLogic is heavy, so you'd need a pretty beefy platform for it. So next question is, can you specify any benefit from running a container app service on an app services compared to AKS? That's a good question. The AKS is a more AKS. The major benefit of running an app service is if you have something that is a smaller deployment, such as, you're not running a large container deployment, say maybe 2 or 3 containers, maybe a main container and a sidecar container, or something like that, where you don't need that big container orchestration like AKS provides, then app services makes a lot of sense. If it's a web app and it doesn't need all that container orchestration. So like that last example I gave you, it was a rather esoteric use case that wasn't a native deployment. I don't need Azure. I don't need Kubernetes to run that single container. That would be overkill. So what I can do with the container, wrap up something like that in a container and then deploy it on app services. So if you had a platform, say something like maybe you're running a Cold Fusion app, and Cold Fusion is not natively supported on app services, you could wrap up Cold Fusion, run that in a container, and deploy that to app services. You don't need all that heavy containerized orchestration like AKS provides. So that's one of the main advantages of it. If you grow beyond a single or a couple containers to run your application, say you don't have the sidecar container anymore, you have something that's more that's growing in its capacity, you have multiple containers supporting an application, that's when AKS becomes an advantage. So this is really designed for small, single or couple container applications. AKS is designed for larger deployments. And so this is intended for more of that smaller deployment, while AKS is to scale it to n number of containers, and it scales to much larger deployments than what app services is generally supported for. Next question is question about deploying to app services, Azure deployment slot. Okay, here, let me read this. Question about deploying to a slot. Azure DevOps deploys to the same slot by name. It's not public facing. Then I swap Then I swap slots. Does that mean that the slot I use the name is production? And if I deploy it again, will it overwrite the slot of potential downtime? What's the best practice? Okay, I think I understand the intent of this question. Basically, like if you tell app services, if you tell Azure DevOps or GitHub, whichever it may be, to deploy to a specific slot, it's going to overwrite whatever is in that slot. Now, if you swap it with the production slot, the production slot takes on that it changes the name of it. So the next time you deploy, it's not going to overwrite the production slot. It's going to be whatever you swapped it with. So whatever was in production prior to your new deployment is going to be overwritten by the third deployment. So the original deployment gets swapped out with the second deployment. I do a third deployment. That's going to overwrite what was originally in the primary one, the first one. And so that one gets overwritten. And then that process repeats with every other deployment, depending on what's going to be deployed in that automatic swapping. So if you want to have multiple versions of it, you can configure your deployment to not to deploy and then automatically swap. You can have up to 10 deployment slots, or depending on the tier. I think some of them have 3, some of them have 5, some have 10. And you can swap V1, V2, V3, or pick a scheme that's going to work for your option there. The best practice though is generally for QA to have its own app service plan and own environment, deploy to that, make sure everything's working there, and then deploy to a deployment slot, then automatically switch it. It'll minimize downtime, basically because all it's doing is a DNS swap at that point. And then everything is DNS on the back end, not front end. The DNS back end is swapped. All the traffic gets routed to the new instance to the new production instance. You might have very minimal downtime for depending on how long it takes your app to start up, which can be, milliseconds depending on the application framework, or the first request is the one that starts it, whatever it might be. But you're going to have minimal downtime if you can deploy it to it, run some smoke tests against that deployment slot, everything's up and running, and then do the swap, and then it's pretty much instantaneous at that point. So let's see. The next question is why not container instances or Kata-based serverless deployments? Again, containers on Azure are multifaceted. There is a ton of different options. I know about with containers, you have container Azure and container instances. You have container apps. You have AKS. You have app services. You have Service Fabric. You can use OpenShift. There's a ton of ways to run containers. They're not apples to apples. So like, why not use container instances or Kata for serverless containers? They're all depending on the workloads that you're running. App services has its place for the kind of app I just showed you, where I had a single container that's really not serverless. It's really not even a service application. It's a great use case for it. If you wanted to deploy that I have deployed that same demo on container apps with that, which is based on Kata. It worked fine. I've deployed it on AKS. I've deployed it on container instances. It worked in every case. It just depends on whatever your container apps, whatever the best use case for your application is going to be for containers is the one that you're going to choose. And so app services is an option. It is not the only option. So would I use it for some things? Yes, absolutely. Am I going to use it for everything? No, it's not my thing. It's just another tool in the tool bag for running containers in Azure. It's one of the many ways to run containers on Azure. I really like all of them for various reasons. Mostly use container instances for virtual nodes on AKS for that more bursty, or for that more ephemeral compute. And so if I need to run like crons on AKS, container instances with kubelets, virtual kubelets on using container instances with AKS is one way to run that. Container apps is Kata based. It runs great for microservices because it's squarely aimed at that. That's what it's for. Use it for that. That's what it. I mean, if I was writing Greenfield and I was writing Kata, I would use container apps all day long, every day. If I don't have that luxury and I'm using something that's more legacy, I might have to use AKS. I might have to use something like that. So it's not a one size fits all. There's a lot of different options there for containers on Azure. So, but again, app services doesn't require containers. It's a versatile app. It's a versatile app hosting platform, as we've seen already. It's just containers are an option in the myriad of ways that you can configure app services to run. So I hope you got a taste for that when we ran, just a myriad of different things in app services here today. So again, that's just a lot of different things there. So I think that's all the questions. Thank you guys for coming out. We will be posting the recording of this on our YouTube channel. So if you want to check that out at some later date, and we'll definitely, if you have any questions, please feel free to reach out to me online. You can ping me on Twitter here at the One Mule on Twitter, or you can just email me, blazestewart@amacera.com. I'll be glad to field any questions that you might have regarding app services or any of the other tech that we've talked about today. Thanks for coming out, and I look forward to seeing you on other engagements that we might have in the future on Amacera's options here.